Welcome back to the YouTube channel RK's Electric World. So in last lecture we have discussed that we have started the fundamentals of electrical engineering. In that we have covered the basic concept, that is definition of charge, current, voltage, power, energy. Then what is electric potential, potential difference, what is resistance, conductance and resistivity. So now in this lecture we are going to discuss about our second point under the fundamental of electrical engineering, that is electrical units and system measurement. So kindly note that as a part of the basics we are revisiting these units for recall purposes. Each unit will be discussed in more depth and detail when we cover its related concept later while studying that particular chapter. This brief overview is intended purely to help you remember and understand them easily at this stage. So, okay, let's start the electric units that basically used in electrical engineering. So, which are the different parameters that used in electrical engineering? We'll discuss about their units. Okay, so let's recall first, that is the nothing but the charge, which is denoted by Q, having a unit is coulomb and which is denoted by capital C. Second one is nothing but the current is having the unit, that is ampere, which is denoted by capital A. Then voltage, which is having the unit, that is volt, which is denoted by capital V. Then resistance having the unit ohm. Next, power is having the unit, that is watt. Then energy is having the unit, that is nothing but the joule, which is denoted by J or kilowatt hour. Then capacitance, which is having the unit, that is nothing but the farad, which is denoted by capital F. Then inductance having the unit Henry, which is denoted by capital H. Then magnetomotive force, which is having the unit, that is nothing but the ampere turns, which is denoted by capital AT. Then magnetic flux density, which is having the unit, that is nothing but the Tesla, which is denoted by capital T. Then magnetic flux is having the unit, that is the Weber. Then self-inductance, which is having the unit as same as the inductance, that is Henry, which is denoted by capital H. Then mutual inductance is also having the same unit, that is Henry. Then permeability, it is having the unit, that is Henry per meter, H per meter. Then conductance, it is having the unit, that is nothing but the Siemens, or we can say that is the mho, that is inverse of resistance. Then impedance, which is having the unit same as the resistance, that is ohm. Then reactance, which is having the unit same, that is ohm. Then admittance, it is that is a reciprocal, that's why the admittance having the unit, that is the Siemens. Then active power is having the unit, that is nothing but the watt. Reactive power, that is having the unit, that is nothing but the watt, VR. Then apparent power, it is having the unit, that is nothing but the volt ampere, which is denoted by capital VA. So in depth about these particular formulas that we will discuss in that particular chapter, means that in DC circuit, in magnetic circuit, in AC circuit, how these units come, that we will discuss. This is only for the reminding and understanding purpose, or you can easily recall from this one single video. Okay, then there are some derived units also in the basics, so we'll discuss that one, that is derived formulas for particular concept. So voltage, that is nothing but the work per charge, it is having the unit that we have discussed the volt. Then resistance is nothing but the, that is the voltage per current. Then capacitance is nothing but the charge per voltage. Inductance is nothing but the whole second per ampere, having the unit, that is the Henry. Electric charge, that is nothing but the current into time. Conductance, it is nothing but the 1 divided by resistance, that is reciprocal of resistance, having the unit, that is Siemens. Then power is nothing but the voltage into current, having the unit watt. Then energy per work, that is nothing but the power into time. Then magnetic flux is nothing but the induced EMF into the time, having the unit, that is Weber. Magnetic flux density, that is nothing but the magnetic flux divided by area. So flux having the unit, that is Weber. Area, it is having the unit meter square. So Weber per meter square we can also write. So magnetic flux density, it is having the unit Tesla. Electric field, that is nothing but the voltage per distance, having the unit volt per meter. Then current density, that is nothing but the current divided by area, ampere per square meter. Then conductivity, it is a reciprocal of resistivity, so 1 by resistivity. Then permittivity and having the unit, that is farad per meter, and permeability is nothing but the Henry per meter. So here is some derived formula for the particular quantity of electrical engineering. Then which are the some prefixes that is used for the electrical quantities contained? So generally we are using the prefix, that is the milli, which is denoted by small m, having the value that is nothing but the 10 raised to power of minus 3. Then micro, that is having the power, that is 10 raised to power minus 6. Then nano, which is denoted by small n, it is having the value, that is the 10 raised to power of minus 9. Then kilo, which is denoted by k, having the power, that is 10 raised to power of positive 3. Then mega, which is denoted by capital M, having the power, that is 10 raised to power of 6. Then giga, which is denoted by G, and having the power 10 raised to power of 9. So these are the prefix that is used for the particular quantities of electrical engineering. So for example, here I have mentioned that 1 kilovolt is nothing but the 1000 volt, means that kilo is having the value, that is a 10 raised to power of 3. 10 raised to power of 3 means you have to just multiply 1 with the 10 raised to power of 3, means that it will become the 1000 volt. Same next example, 1 microampere. 1 microampere means that 10 raised to power of minus 6. So according to the power, you have to shift the point from right or left, so according to that particular value. So here 1 microampere is given, so value is 0.000001 ampere. So next one is a 5 milliohm. So 5 milliohm is nothing but that is a 10 raised to power of minus 3. To convert this 5 milliohm into the ohm, you have to multiply this 5 with the 10 raised to power minus 3. So it will become the 5 milliohm to the 0.005 ohm. Okay, so these are the prefixes that generally we are using for the electrical quantities. Then unit conversion. So how this unit conversion takes place? So unit conversion techniques, that is use the prefixes multiply. Already you have discussed this. Milli is nothing but the 10 raised to power minus 3. Kilo is 10 raised to power of 3. So for the unit conversion from this milli kilo to that particular value, so you have to move the decimal point. So decimal point left or right based on the power of 10. So here some examples also given, that is 1 milliampere is equal to the 0.001 ampere, means that to convert this 1 milliampere into the ampere, we have multiplied with the power of 10 raised to power of minus 3. That's why we have shifted the pointer like this one. The next example, that is the 5000 millivolt. So 5000 millivolt, to convert into the volt, you have to, this milli is nothing but the 10 raised to power of minus 3. So it will become 5 volt only. Then last 2 kilo ohm, that is kilo is nothing but the 10 raised to power of 3. So you have to multiply 2 into 10 raised to power of 3. So it will become a 2000 ohm. So thank you. This is for today's lecture, that is related to the electrical quantities unit and which are the different prefixes that is used for this particular electrical